we'll see. Now, ladies and gentlemen, the inequalities, just the linear inequalities, that's all Algebra 1 stuff. That's stuff you did 2 years ago. Now, when we get into systems, what we need to do is we're going to do the same thing, but we're going to do this twice. So you're going to take this first equation and you're going to perform that entire step to it. So I want to graph y equals 4x minus 3. So I'm at negative 3. My slope here is 4 over 1. So that's up 4, right 1. 1, 2, 3, 4, 1.
Why is it y equals 4x?
Because I want to graph the line that's associated with this inequality. Now, is this top one, is this going to be dashed or is it going to be solid? It's dashed. Alright, so this is y is greater than 4x minus 3. Now, what test point can I use 0, 0 as a test point? Okay, so I can use 0, 0. So I'll get 0 is greater than or equal to 4 times 0 minus 3. So 0 is greater than or equal to negative 3. Is that true or false? Or greater than? Alright, so it's true. Now, when you're trying to solve a system of inequalities, don't shade with a pencil. If you're going to shade with a pencil, use a colored pencil. And use different colors. And I would recommend a highlighter. Yeah.
Why is it, like, when you wrote it out, instead of equation, why is it greater than or equal to when it was just...
I put the equal sign. It shouldn't be greater than or equal to. It should be just greater than.
Okay.
Alright, now we're going to take the second one. Is this going to be solid or is it going to be dashed? It's going to be solid. So I need plus 3, so I need to start at positive 3. And my slope is negative 2. 2 down, 1 to the right. Now, can I use 0, 0 as a test point for this? Yes, because 0, 0 is not on that line. But first off, what happened, once I graph these two lines, you have 4 different regions that these two lines, when they cross each other, cut the graph into. One of these regions is going to be the solution region. So far, I've narrowed it down to 1 or 2 because that is a solution to the first inequality. I got to figure out now where the solutions are for the second inequality, because then that's going to narrow it down even farther. So I need that y is greater than or equal to negative 2x plus 3. I'm going to use my test point of 0, 0 again. So 0 is greater than or equal to negative 2 times 0 plus 3. So 0 is greater than or equal to positive 3. So is that true or false? Alright, so it's false. So I'm going to graph. I'm going to graph away from the test point. So I'm going to graph up here. Now, which one is a solution region for both of them at the same time. Where's the overlap? So this region, this second region up here, these are where all my solutions are.
Okay, so if you, like, does it have to be 1, 2, 3, like in that order, or can you put,
No.
like, one?
I just put 1, 2, 3, and 4 just to show you that there were 4 regions. You don't have to number the regions at all. And that was just purely for instructional purposes. It's just this area up here, this little wedge, is our solution region. This one works for one of them, this one works for none of them, this one works for one of them, and this one works for both of them. So your job is going to be trying to find the regions for both of them. And it's that overlap that's going to work. Now, I'm just going to show you this right here because the question came up from number 4 on the first page, where it was y is greater than -4. This is y is greater than -2. When you only have like y equals, when you just have y and no x and x and no y, these represent horizontal or vertical lines. This one just happens to be horizontal. A good way to remember how to graph this is say, all right, this is y is greater than -2. Go to the point y equals -2, put a dot there. What axis are we on? Are we on the x-axis or the y-axis? We're on the y-axis. What I want to do now is I want to draw the line perpendicular to that axis. So I'm going to draw a line that is perpendicular to the y-axis, so that's going to be a horizontal line. Now, is it going to be dashed or is it going to be solid? It's going to be dashed. The nice thing is, all we have to do is follow the line on the graph. We can do this one almost by sight. Is 0 greater than -2? Yeah. So for this guy, that's the half that it was cut into. So that's how you work with a horizontal line. Whenever it says y equals or y, like y equals 2, y equals 7, y is greater than -3, it's always going to be that horizontal line. So y is always horizontal. X is always vertical. Now for the other line, y is greater than or equal to -5x plus 3. There's your 3. -5 is our slope, so 1, 2, 3, 4, 5, 1. Is this a solid or a dashed line? Now, can I use 0, 0 as my test point?
Wait, when would you not be able to?
If it was on the line. If the line goes right through 0, 0. Alright, so I can use 0, 0. So my y becomes 0. It's -5 times 0 plus 3. 0 is greater than or equal to 0 plus 3. So is 0 greater than or equal to 3? Yeah, this is false. So we're going to shade away from that. So there's the point, so I want to shade up this way. So where's my solution region? This region right here. That's the overlap. And best thing to do is just write in solution region. Now, if you don't have colored pencils or something like that, an easy way to kind of show where all the solutions are, is to use arrows. If you know you're going to shade up from this dotted line here, you can shade like that. And if you're shading down here, now of these four, which one has both of the shading in it? That region over here. This one has all the solutions from this line here. This has no solutions. This only has one solution. This is your solution region. So you just need to be able to keep track of it. That's why highlighting is really, really good, where colored pencils are really, really